In this video, we are going to look at few more variables which are implicitly initialized by CUDA runtime. Let's start our discussion with block IDX variable. CUDA runtime uniquely initialized block IDX variable for each thread depending on the coordinates of the belonging thread blocks in a grid. This variable is also dim3 type variable which have x, y and z values. For example, here we have one-dimensional grid with 8 threads which are arranged into 2 thread blocks in x dimension. In y and z dimensions, there are only 1 thread blocks. So, block idx.y and block idx.z variables are 0 for all these threads. But we have 2 thread blocks in x dimension. So, threads in the first thread block will have block idx.x value 0 and threads in second thread block will have block idx.x value 1. Remember, block idx variable initialized based on the thread block. So all the threads in the same block will have same block idx values. Let's see another example now. In this example, we have two-dimensional grid with 2 thread blocks in each dimension and each thread block have 4 threads in x dimension. Here I have named some of these threads with letters. So let's assign block IDX values for each of those named threads. This is going to be very easy if we can imagine this grid in a Cartesian coordinate system and then divide thread blocks into slots as shown in this diagram. So here P and Q threads are in the thread blocks with index 0 in both x and y dimension. So block idx.x and block idx.y values are 0 for P and Q threads. R and S thread are located in the thread block with index 1 in x dimension and index 0 in y dimension. So block idx.x value is 1 and block idx.y value is 0 for both of these threads. T and U threads are at the thread block with index 0 in x dimension and 1 in y dimension. So block idx.x is 0 and block idx.y is 1 for these threads. V and X threads are located in thread block with index 1 in both x and y dimension. So both block idx.x and block idx.y values are 1 for these threads. Again, you can see that for threads within the same thread block, we have same block idx values. Let's look at another example now. Here we have two-dimensional grid with 2 thread blocks in x and y dimensions, and also thread blocks itself are two-dimensional. But still, all the threads within the same thread block is going to have same block idx values regardless of the thread block's dimension. So here also, block idx.x and block idx.y values for x and y thread is going to be 0. For P and Q threads, block idx.x is 1 and block idx.y is going to be 0. And for R and S threads, block idx.x value is 0 and block idx.y value is going to be 1. And for T and U threads, block idx.x is 1 and block idx.y is 1. Next variable we are going to discuss is block dim variable. Block dim variable consists dimension values of a thread block. Notice all the thread blocks in a grid have same dimension values. So this variable value is same for all the threads in a grid. This variable is also dim3 type variable which have x, y and z values. For example, this diagram shows a grid with 32 threads which are arranged to 4 thread blocks, each having 4 threads in x dimension and 2 threads in y dimension. So block dim.x is 4 and block dim.y is 2 for every thread in this grid. Grid dim variables consist number of thread blocks in each dimension of a grid. This variable is also a dim3 type variable which have x, y and z values. For example, grid shown in this diagram have 3 thread blocks in x dimension and 2 thread blocks in y dimension. So for this grid dim.x value will be 3 and grid dim.y value will be 2. Okay, now I am going to print out the values of the variables we discussed in this video. So here I am going to use same grid we launched for our previous video which had 256 threads arranged into 4 thread blocks each having 64 threads as shown in this diagram. Okay, Let me show you the implementation now. This implementation is almost similar to one we had in the previous video. So I have copied that code here. Our main function is same as before. We set grid and block variables and we launch the kernel with those parameters. But we have to change our kernel a bit. So let's rename our kernel to print detail kernel. Now let's print out block IDX values, block dim values and grid dim values instead of thread IDX values. Okay, now let me run this example. In this output, you can see that for all the threads, block dim and grid dim values are same. Block dim.x and block dim.y values are 8 as we have 8 by 8 thread blocks, and grid dim values are 2 as we have 2 thread blocks in each dimension. And we can identify threads within the same thread block by looking at block IDX values.